Hey guys, this is Mr. Anziano. I only have about 8 minutes before the bell rings, so I'm going to record a super quick video on 7.0 to 7.3 review. It's at the front of section 7.4 of our notes, and so here goes. First, we have to find, for these two angles, for A and B here, we have to find that angle in standard position and draw it, and also find the measure of the reference angle, a positive coterminal angle, and a negative coterminal angle. All right, so that's going to require that we draw our X and Y coordinate axis. Sorry, this is going to be a little bit messy as I'm trying to go quickly here, but bear with me. So negative 473 degrees. We know that that, first of all, is negative, which means we're starting by going down this direction clockwise, right? Clockwise is negative. We also know that it's more than 360, so I'm going to go all the way around one full revolution and then kind of just count out what I need to go from there. So after 360, we need to go for sure another 90, right? Because that would take us to 450, and then we need to go another 23 degrees past negative 450. So negative 23 degrees past that's going to put me about right there. Okay, so we draw a little arrowhead at the end of our swirly angle, and we're going to draw the terminal side of the angle to meet that ending point. And of course, the initial side was right there on the x-axis. So there's our angle in standard position. That is negative 473 degrees. Okay, then it says find the measure of the reference angle. Well, the reference angle is the distance that that angle creates from the x-axis. So that right there is our reference angle. I'm going to call it theta. Okay, our reference angle has a measure of whatever the distance is from the x-axis to that ending point, right, to the terminal side, and that was 23 degrees past this negative 450, excuse me. It was 23 degrees past negative 450, right? So really that means that the distance that this angle creates from the x-axis is going to be 90 degrees minus 23 degrees, which is actually 67. So 67 degrees should be our reference angle. Okay, and then it says find a positive and negative coterminal angle. Well, all we need to do is add 360 to negative 473. So if we add 360 degrees one time, we're still going to get a negative angle. That turns out to be negative 113 degrees. Okay, which is a negative coterminal angle, right? Still negative. So now we need to add 360 again to get a positive coterminal angle. So I'm going to add 360 to negative 113, which is the same as subtracting 113 from 360, and we get 47 degrees, 247 degrees. And that is a positive coterminal angle, right? So there's two angles that are both going to end right there, as well as negative 473. That makes them coterminal. And let's move on to our radian situation in letter B. 13 pi over 7. If you're in my class, you've heard me say a number of times now, we start by figuring what is 13 pi over 7 really close to, right? Well, to me, I see that that's really close to 2 pi. So right off the bat, I know that my angle, 13 pi over 7, is going to be almost one full revolution, but not quite. In fact, it's just 1/7 of pi short of a full revolution, right? So there's my terminal side. We measured by going that direction. This time we went counterclockwise. And of course my initial side is right there on the positive x-axis. Okay, so that is 13 pi over 7 in terms of radians. Next we need to find our reference angle, the distance from the x-axis, right? The angle that the x-axis creates with the terminal side. And that is going to be, we just said that's pi over 7 away from 2 pi, right? That means that this angle right here, this little space, this little gap, is going to be exactly pi over 7. Okay, and that's pi over 7 away from the x-axis. So now we just add not 360 anymore, but actually 2 pi to get a coterminal angle, a positive coterminal angle in this case. But how do we add 2 pi to 13 pi over 7? Well, that's the same as taking 13 pi over 7 and adding, well, 2 pi in terms of sevenths is going to be 14 pi over 7, right? So 13 pi over 7 plus 14 pi over 7 is going to equal 27 pi over 7. Okay, and if we subtract 2 pi from 13 pi over 7, that's the same as subtracting 14 pi over 7 from 13 pi over 7, and we get negative pi over 7. So there's my negative coterminal angle. here was my positive coterminal angle, and that's it for letters A and B for the first section. Next, for section number 2, for each angle described below, determine the quadrant or axis in or on which the terminal side of the angle lies. If no such angle exists, state why. Justify your answers. Guys, this is going to require that we remember that the tangent of theta is equal to the sine of theta over the cosine of theta, or more simply, y over x. Okay, that's going to be useful here, and I'll explain in just a minute. So here is our coordinate plane. We're going to start there. Now, the question is, right, I can go this way, or that way, or that way, or that way, right? I can make a drawing, I can make my line go into any of the 4 quadrants. However, only one of those quadrants is going to satisfy both of these requirements, or perhaps none of them are going to work. It says if no such angle exists, state why. So that's also a possibility. So let's figure, what does it mean for the cosine of theta to be negative or to be less than 0? That means that the x value has to be less than 0. And in which of the 2 quadrants are the x values less than 0? Well, it's either going to be over here in the second quadrant or down here in the third quadrant. So we can automatically cross those out. We know that those aren't going to work. Okay. Again, kind of a crude drawing, not very precise, but it'll work for this. We also need to figure out where are the tangent values going to be negative. Well, tangent of theta will be less than 0 when we either have negative y over x or positive x over negative y. Wait, hang on. That's not right. That's negative y over positive x over negative y. Is that right? No. Okay, I did something silly. We don't want x over negative y. We're dealing with tangent, and tangent is going to be sine over cosine, or we said over here y over x, right? So it's either negative y over x or positive y over negative x. That's better. All right, so the bell just rang while I paused to fix my mess, so I'm going to have to wrap this up here. So if we have either negative y over positive x or positive y over negative x, that's how we get, we figure out which of the remaining 2 quadrants we're in, right? And that's going to be in, well, what are the x values? They're negative, right? So we know that the y values have to be positive. So really that's why we know that we are going to be in quadrant number 2. That was the answer, and that's the explanation. Okay, for cotangent, we know that if tangent is equal to y over x, then cotangent of theta is going to equal x over y, right? And for cotangent to be undefined, that's going to happen when y equals 0, because then x over 0 will be undefined. So the question is, when is y equal to 0, right? Well, y, if you have your unit circle, y is going to equal 0 either there or there. That is not a very centered circle. Excuse me. So, at what point is our y value equal to 0? It's going to happen over here at 1, 0 or negative 1, 0. All right? And we also need to satisfy that the cosine of theta is less than 0. That means that the x values are going to be less than 0. Or negative, right? And where are the x values negative? Right over here on the negative x-axis would have been the answer to that one. Right? So that's how we satisfy both of those requirements. So, looking here at number 3, and I'm going to do this really quickly because I need to start 7th period. So, looking at letter A, we have the angle alpha is passing through the point 5, negative 3. So I'm just going to draw a quick drawing, right? To pass through 5, negative 3, we go over 1, 2, 3, 4, 5, and down 1, 2, 3, right? That triangle right there is the triangle that goes out positive 5 units in the x direction, down negative 3 units in the y direction. That's our triangle, okay? So we have an x value of 5, a y value of negative 3. We need to quickly use the Pythagorean theorem to figure out what the hypotenuse is. I'm going to call the hypotenuse r. So we have 5 squared plus negative 3 squared is equal to r squared. So we have 25 plus 9 equals r squared, and that means that r squared is equal to 34. So r equals the square root of 34. That's our hypotenuse. That's all we really needed. So now, if you need to find the values of all 6 trigonometric ratios of the angle theta, you just list them out. The sine of alpha is going to equal the side, here's alpha right here, right? It's going to equal the side opposite alpha over the hypotenuse. We just solved for the hypotenuse, so that's going to equal negative 3 over the square root of 34, but you can't have a radical in the denominator, so we rationalize by multiplying top and bottom, and we get negative 3 rad 34 over 34 for sine. Cosine of alpha is going to equal the x value over the hypotenuse, right, the adjacent, so we get 5 over rad 34, which is going to rationalize to 5 rad 34 over 34. The tangent of the angle alpha is going to equal the opposite over the adjacent. That's easy. That's just negative 3/5. And the reciprocal functions, guys, remember it said 6, right? 6. That's a big reminder that we need to find the reciprocal functions as well. Nope, I'm off screen. Okay, so the other 3 that we need are, the one that partners with sine is cosecant of alpha, and that's going to equal the opposite of what sine was, right? So we're actually going to get, it was just negative 3 over rad 34. So if I go back to this one right here, then I can write the cosecant of that angle as rad 34 over 3, but that fraction should be negative, okay? And then the secant of alpha, same thing. We're looking at this guy now. That's going to be rad 34 over positive 5. And finally, the cotangent of the angle alpha is going to be the reciprocal of what tangent was, and that's going to be negative 5 over 3. So there are all 6 of our trig ratios. I trust that you guys would be able to do the same to figure out the ratios for letter B. Thanks for watching. Hope you guys have a great weekend, and I will see you